Greetings, everyone. Your favorite math teacher. Let's take a look at graphing absolute value equations today. So we're expanding beyond just lines. I love absolute value equations just because they're always so symmetrical and they seem to just follow the rules to a T. And so I hope you enjoy them as much as I do. Key thing you're going to need as we go through this video is make sure you have a writing utensil, of course your notebook, and a calculator might be helpful, or just pop open Desmos so you can go in between your tabs. We definitely want to jot down this example in our notes. Let's take a look at how to graph the equation y equals the absolute value of x. Now we're going to start by using tables. As we go along, there are faster ways to graph absolute values. And we'll get there, but let's just start off with table of values, as that's something you're very familiar with, so it should go pretty quickly. To start off, we want to take a bunch of x values and plug them into our equation y equals absolute value of x. So I have to pick some x values. So I'm going to start, I definitely want to use an x value of 0. And you know what, I'm going to use some even numbers. I'm going to say -2 and -4, and I'm going to go symmetrical 2 and 4. What we want to do is we want to plug that x value in for x. Therefore, if I plug it into the equation, it looks like this. The absolute value of -4 would give me a y value of 4. If y was equal to the absolute value of -2, then y would be 2. If I plug in 0, it would still be 0. If I plug in 2, absolute value of +2 is +2, and the absolute y value of 4 is 4. Let's plot those points on our graph. So I have -4, 4. I have -2, 2, 0, 0, 2, 2, 4, 4. I love that symmetry. It makes it so easy. Now my lines are probably going to be pretty bad since I'm drawing on a tablet. So yours should end up being a little bit nicer since you're on paper. Vertex, just as it sounds, where's the vertex occur on this graph? It's at the point 0, 0. So maybe make a little note off to the side that the vertex should be written in point form. Okay. Let's take a look at our domain and range. Domain, we're going to keep stressing this as I did in my last video. Domain is how far left to how far right. My graph goes forever left and forever right. So it includes all x values forever. The Sandlot reference if you haven't seen that movie. All right, let's take a look at the range. Range is how low to how high. How low? Oh, I only go down to this value right here, and that's at 0. And we include our 0, so I'm going to use a bracket. Okay, those are our y values, don't forget. How high does the graph go? Well, it keeps going up, 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 up on both sides. So infinity would end that range. All right, let's take a look at another example. Definitely want to jot down this equation. Feel free to use Desmos if that helps you understand this concept. We want to pick some x and some y values here. So I'm going to always use 0. I like using 0 because it's kind of easy to plug in first of all. And I'm actually just going to stick with that -2, -4, 2, 4. Okay. If it doesn't give you what you need, then add some values if you need to see more information. Okay, that means I need to plug in -4 into my equation. -4 plus 3 is -1. The absolute value of -1 is 1. 1 minus 4 gives me -3. Let's try it with our -2. The absolute value of -2 plus 3 gives me absolute value of 1. 1 minus 4 gives me -3. Interesting. Let's take a look at our 0. If I plug in 0, 0 plus 3 is 3. The absolute value of 3 is 3. 3 minus 4 is -1. Plug in 2. The absolute value of 2 plus 3 is 5. The absolute value of 5 minus 4 is 1. And if I plug in 4, I want the absolute value of 4 plus 3, which gives me the absolute value of 7. The absolute value of 7 is 7. 7 minus 4 is 3. I'm not noticing that symmetry, so let's plot the points I have and see maybe what points I need to add. So we're at 4, 3. We're at 2, 1. We're at 0, -1. We're at -2, -3. We're at -4, -3. It looks like I've changed direction. So if I was to make a guess, I mean, I can kind of see where I think my y is, right? Or excuse me, my v shape, where my v shape is. So I'm going to add a couple extra values here. I feel like adding a -3 might be helpful. And I'm going to add a -5. Sorry, I'm going to write above the table here just due to space. So if I plug in a -3, -3 plus 3 gives me the absolute value of 0, which is 0. 0 minus 4 is -4. -5. Now, you don't have to write this all out. If you can do this mental math, that is awesome. I'm a visual learner, so to check my work, I definitely need to write it out. So I've got a -5 plus 3. The absolute value of -5 plus 3 gives me the absolute value of -2. The absolute value of -2 is 2. 2 minus 4 is -2. Let's see, now I've got the point -3, -4. Okay, that looks better. And -5, -2. Now I can clearly see my V. Okay, very helpful. I don't need to do any more points because I know where it's going to go. So our vertex is also our minimum in this case, right? Because it's a bottom and it's a point. Our minimum occurs at -3, -4. Hey, look at those numbers, -3, -4, 3, -4. Look at these patterns as we go through and use these tables. It's going to make some understanding a lot clearer. Domain. Our domain is how far left to how far right. I go forever left, forever right. You'll notice this trend with our absolute value functions. Our range is how low to how high. How low. It goes as low as -4, and I include it. And it goes as high as forever, infinity. I've got another one here. Jot down this one. You'll notice now I have a number in front of the x, so watch out for that. Okay, for x values, I'm going to use 0 again. Okay. Now I'm going to take some information from that last one and make note of this 1 right here. I wonder if that makes a difference. So I might actually use -1, -2, and 1, 2. See if we end up with any symmetry amongst there. All right, so if I plug in a -2 into my equation, oops, it's up. Well, let's try this again. Okay, let me fix my mistake there. So I've got the absolute value of 2 times -2 plus 1 minus 4. -2 times 2 is -4. -4 plus 1 is -3. The absolute value of -3 is 3. 3 minus 4 is -1. All right, the absolute value of 2 times -1 plus 1 minus 4. The absolute, or excuse me, 2 times -1 is -2. -2 plus 1 is -1. I want the absolute value of -1, which is 1. 1 minus 4, -3. 0. 2 times 0. plus 1 gives me 1. The absolute value of 1 minus 4 gives me negative 3. Interesting. Notice some patterns already. 1, 2 times 1 plus 1. Oops. 2 times 1 is 1. 1 plus 1 is 2. Absolute value of 2 is 2. 2 minus 4 gives me negative 2. And if I plug in 2 times 2 gives me 4. 4 plus 1 is 5. The absolute value of 5 is 5. 5 minus 4 is 1. All right, let's plot these points. You might be able to kind of see where this is going already, which is my hope. Negative 2, negative 1, negative 1, negative 3, 0, negative 3, 1, negative 2, and 2, 1. You can kind of see where this is going. I almost feel like I need to do a half in there. Let's add that. Let's do a half point. If my x value was negative half, because I feel like there's a v in there somewhere. The vertex should be in there somewhere. So I'd have 2 times negative half, right? Plus 1 minus 4. 2 times negative half, or what's half of 2 is 1. It'd be a negative 1 plus 1, which can be 0. The absolute value of 0 minus 4 is negative 4. So at negative half, I'm at negative 4. Okay, so do I have my perfect v here, or did I make a mistake somewhere? Let's take a look. I did make a mistake. Does anybody see that? Okay, how do I know I made a mistake? And I note here, I might have done this on purpose just to make you think about this. I know that on the previous ones, everything was symmetrical. It's not symmetrical. It looks like the bottom 3 are. So it looks like maybe my 1 value is off. So let's correct my work and let's go to where I plugged in 1. 2 times 1 is 2. 2 plus 1 is 3. The absolute value of 3 is 3. 3 minus 4 is negative 1. Let's see if that fixes my mistake. Cross that off. I'm going to be at 1, negative 1. Hey, that looks better. Therefore, now I have my perfect symmetrical V shape. Okay, that's what I love about absolute values. You know if you're doing it right or not. It's so awesome. All right, my vertex, let's take care of that, is that value I found, which was negative 1/2, comma, negative 4. It's a point, write it as a point. Domain and range, domain, forever left, forever right. You'll notice a pattern that keeps happening. My range is how low to how high. How low do I go? Well, my lowest point is my vertex, and that's my y values of negative 4. I include it, and I go forever high, so infinity. Okay, so again, if it doesn't look symmetrical, check your work. Alrighty, let's do one more example. This will be our last one for this video. Make note of some of these numbers, okay? We have a 2, negative 2, or subtract 2, depending on how you want to look at it right now, and a 3. So I'm actually going to do a 0 again. I'm going to do a negative 2 and a negative 4, and a 2 and a 4. See what happens there. Okay. Notice there's a negative in front of the absolute value sign. That might make a difference. All right, our first value, negative 4 minus 2 is negative 6. The absolute value of negative 6 is 6. But then I have that negative out front, which makes it negative 6 again. So try and keep track of all of those negatives. Negative 6 plus 3 gives me negative 3. Do the same thing. I'm not going to write all of these out, okay? But be very careful with those signs. -2 minus 2 gives me -4. The absolute value of -4 is 4. Throw a negative out front, -4. -4 plus 3, -1. Let's do a 0. 0 minus 2 is -2. The absolute value of -2 is 2. Throw a negative out front, -2. -2 plus 3, 1. If this gets confusing, make sure you write out the steps. It'll help you understand it. It's worth it, you guys. All right, let's do a 2. 2 minus 2 is 0. 0 is neither positive or negative, so it's going to be 0 all the way. 0 plus 3. And let's look at 4. 4 minus 2 is 2. Throw a negative out. Absolute value of 2 is 2. Throw a negative out front, -2. -2 plus 3 is 1. Let's plot our dots and see if I've got some symmetry going on. If I need to add a point, -4, 3, -2, -1, 0, 1, 2, 3, and 4, 1. Oh, I went back down. I'm noticing a little bit of symmetry there. Maybe looks like my V is upside down. Let's see, if I was to do 6, let's add the value of 6 onto here. See what happens. I'm going to throw it up top here. 6 minus 2 is 4. The absolute value of 4 is 4. Throw a negative out front. -4. -4 plus 3, -1. So it's 6, I'm at -1. Okay, I'm confirming what I thought was true. And you guys, I'm doing these straight from scratch. I didn't even plug them in or check my work beforehand. So I'm with you as I do these examples. And so you want to have that same understanding of checking your work. So if I don't see enough of a V, add some points. Make sure that you're correct. So in this case, I do have my clear V. I can take care of my vertex, which is my maximum in this case, because it's at the top, and that'd be at 2, 3. Our domain, I go how far left to how far right, forever left, forever right. My range, is how low to how high. Here's where things change. I go forever low, and I go up to the y value of 3, and it's included. See, I go up to that y value of 3 there. So what's the biggest change you noticed on this question? I hope you're thinking the V is upside down. That negative out front had something to do with that. A negative out front flips your graph upside down. Okay, you're going to notice these themes and these patterns that happen throughout this entire unit. Okay, let's take a look at a summary here. Jot a few of these things down because they might be helpful as you progress through some examples and practice problems. First of all, we've made note that it's always a V shape. If it doesn't look like a V shape, check your work, something's wrong. We found the vertex kind of by guess and by golly, but as we progress through here, you can find the vertex by finding the x value that makes the absolute value expression 0. So for example, if I have something like x plus 3, that would mean, hey, -3 would make it 0. Therefore, my vertex is at -3 something. I'd have to plug it in to find out. So keep that in mind. That's a really good note to jot down. Always complete a table. I want to see the work. I want to see that you plugged in points. Plot the points. Of course, you need to see that it looks like a V. Okay? Always look for the V value. Okay? I need to see that V. All right? So take care. I'll be checking out these notes and making sure you're good to go, and we'll see you in class.